All right, y'all. Today we have solving systems of equations. With multiplication and elimination. Okay? So we're talking about solving them using the multiplication first and then doing the elimination. Okay? So, here's an example. We get negative 2x plus 6y equals 16. And we get negative 1x plus 5y equals 18. Alright? So I'm looking at that particular problem and I'm thinking, okay, if we're talking about elimination, I would be trying to add these together to either get rid of the x's or get rid of the y's. But if I add them together, so I'm going to put a star, and this is going to say notice. If I add the x terms, I don't get 0. Same with the y terms. Okay? That's not good, right? Because when I add this, negative 2 and negative 1 gives me negative 3x. That doesn't help me. 6 and 5 gives me 11y. That doesn't help me. My whole goal is to make one of these cancel out, so I have no x's or no y's. So, I have to go back and see, okay, let me look at my x terms, okay? And for my next step, I'm going to say, so step 1 will be decide which terms, x or y, you could turn into common numbers by multiplying. Okay? So what I mean by that, I have a negative 1 and a negative 2. Can I turn a 1 into a 2 by multiplying? Yeah, very easily. I got a 6 and a 5. Now look at this one. I can't turn a 5 into a 6 by multiplying, nor can I turn a 6 into a 5 by multiplying. So this is the one I want to deal with. This is a 2, and I could turn this 1x into a 2. Okay? So, after you do that, pick a value to multiply the entire equation with, so that the x value will cancel out the, you're going to put it down here, I'm just going to write it up here. So the x value will cancel out the x value in the other equation. That really should say the x value in the first equation will cancel out with the x value in the second equation. I didn't actually word that great, but hopefully you'll get the idea. So here, I know that I could turn a 1 into a 2 by multiplying, and I can multiply this whole thing by a 2, right? But I also want to make sure that if this is a negative 2, that this becomes a positive 2, so that they cancel out. So I'm going to multiply the whole thing by negative 2, because here is what I'm going to get. I'm going to keep my first equation, so the first equation stays the same, negative 2x plus 6y equals 16. But the second equation, I change. Negative 2 times negative 1 is positive 2x. See, these are the ones that are going to cancel out. Then I get negative 2 times 5, which is negative 10y. Then I get negative 2 times 18, which is negative 36. This equation and this equation are the same. Okay? They are, maybe you'll want to write it this way. This one and this one are the same equation. Okay? So, now I can go ahead and add. Negative 2 and 2 is 0, so those cancel out. 6 and negative 10 is negative 4y. 16 and negative 36 is negative 20. Now I can solve for y. Divide by negative 4, divide by negative 4, y equals 5. Right? So, now that I found out that y equals 5, I can substitute this, and then we're back to what we've done already. I can substitute 5 back into this equation, or this equation. Doesn't matter which equation I put it into. So let's go here. Negative 2x plus 6y equals 16. Now we know that y equals 5. Negative 2x plus 6 times 5 equals 16. This becomes a 30. To solve this, I do minus 30 on each side. Negative 2x equals, what's that, 14? Negative 14. X equals negative, x equals positive 7. Okay? So that gives me everything. So my final solution to this equation would say that x equals positive 7 and y equals 5. This is the point, okay? And just put an arrow here that says this is the point where the graphs of the two lines would cross. Right? So if I graphed those two lines, hypothetically, this point where they crossed would be 7, 5. Alright, so that's one for you to see. That's the idea of solving systems of equations with multiplication and elimination. Make sure you get all this stuff down. Make sure you're making sense out of what you have written. Talk to you later. Bass.